Hello students, welcome to my YouTube channel UPSU Technical Center once again. Today's my subject is Basic Electrical Engineering as per MACOUT syllabus, and the subject topic is series connections of the following parameters. Parameters are the resistors, inductor and capacitor. First, discuss, resistance, inductance, capacitance. That is the property of a parameter. Like when we talk about the resistance, that is the property of resistor. Inductance is the property of inductor. Capacitance is the property of capacitor. Okay. Now here the three resistances I have considered R1, R2 and R3. Both are connected in series. What will be the equivalent value of R? That is R equivalent is how much? Today I will discuss the formula how it will develop, but you have to remember the formula for solving the problem. As you know, this basic electrical engineering is a common paper for all department, so it is very important for the electrical engineering and the triple engineering, SC engineering and other engineering also, but it is not so important for those stream like computer science, laser technology, IT. Those are not so important, so remember the formula. Okay, but for those students, those are in double E, triple E, C. Okay, those students I must remember that formula. It is very important, as well as the they must remember the concept. And today I will discuss about the concept. Okay. So initially we consider these three resistance are connected to a supply, and this supply we consider like this is plus and this is minus, and this applied voltage is V. Oh, this is connected across this terminal. Okay, and here we consider a current, that is the common current, as it is connected in series flowing through this path. When current will flow through this path, there will be the individual voltage drop, and that drop we can write in such a way that will be current entry at the point, that will plus, that is minus. Here it is plus, that is minus. Here it is plus, and that is minus. And the voltage across this R1 is V1. This is V2 across R2, and across R3 it is V3. Here we see the total voltage applied to the circuit is V, which is the summation of V1 plus V2 plus V3. Okay. Next thing, the total resistances are equivalent, and the total current flowing through this circuit, or the you can say the current flowing through this circuit is the common current, only one current is there, that is I. So total voltage equal to current into total equivalent resistance, that is R equivalent. Okay. V1 equal to I into R1, V2 is equal to I into R2, V3 is equal to I into R3. So here you see I R equivalent equal to I into R1 plus of R2 plus of R3. So R equivalent equal to R1 plus R2 plus R3. In general, R equivalent is equal to R1 plus R2 plus R3 plus Rn. If we connect n number of resistors in series with this circuit. So this will be our formula. Okay, and this formula you must remember at the time of exam when resistance are connected in series, what we need to do. Okay, so this is very important. Next is the inductor. Okay, so here also we consider the current is same as common current I, and this is the applied voltage, this is V, and these are the inductor L1, this is L2, this is L3, and here is a drop, that is plus minus, that is plus minus, that is plus minus. As before, this is V1, this is V2, this is V3. Okay, now in case of inductor you have to find out the L equivalent, right? Okay, I might write in the black. You have to find out the L equivalent. Now question is how? Similarly as before, you know the voltage is the summation of V1, V2 and V3. Here one extra things you have to do. Here inductor is there. You have to find out the reactive inductive reactance XL by multiplying by omega L. Multiplying by omega L. So similar way you can find for the L1, that will be XL1 omega L1 XL2 omega L2 XL3 omega L3. So XL equivalent, that will be omega L equivalent. So the very simple. Okay. Now V equal to this equation, write in a way I into XL equivalent equal to I into XL1 I into XL2 I into XL3. So here you write, if we take a common I and if we write X equivalent equal to, I will be cancelled as V4, you know that XL1 XL2 xl3. And you know x equivalent, that is equal to, sorry, xl equivalent, it is equal to omega l equivalent, omega l1, omega l2, omega l3. So omega will be cancelled as before. So L equivalent is equal to L1, L2, L3. So you can put in a red box, okay, as before. Sorry. This will be our formula. Okay. So remember this. So if we go through the formula, here you can consider for the n number of turns. Okay, it may be you can consider for the n number of turns also. Okay. So just this is the first step. In general, write down in such a way. So remember this. In general, L equivalent is equal to of L1, L2, L3 equal to dot 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 Ln. Now put it in a red box. So that important. Here, in case of resistor and inductor, you see the same formula. As formula is almost same. Okay. Now, here for the capacitor, suppose this is C1, this is C2, and this is C3. Here the current is I. Here the voltage is applied across this is V. And this is positive, negative, positive, negative, positive, negative. This is V1, V2, V3 as before. And you have to find out C equivalent. Very important discussions for case of capacitor when is connected in series. Okay. So here the same as before, V equal to V1 plus of V2 plus of V3, right? Here also you have to find out the XC, the capacitive reactance. That will the formula is different. 1 by omega C. So XC equivalent will be 1 by omega C equivalent. Similar way, XC1 equal to 1 by omega C1, XC2 1 by omega C2, XC3 1 by omega C3. So substitute in such a way V equal to IXC equivalent. IXC1, IXC2, IXC3, X equivalent, sorry, xc equivalent equal to xc1, xc2, xc3. xc equivalent you can write 1 by omega c equivalent, 1 by c omega c1, 1 by omega c2, 1 by omega c3, or we can write 1 by c equivalent equal to of 1 upon c1, 1 upon c2, 1 upon c3. So when both these are connected in series, their formula is 1 by c equivalent equal to 1 by c1, 1 plus 1 by c2 plus 1 by c3. So in general 1 by c equivalent equal to of 1 by c1, 1 by c2, 1 by c3 by 1 by cn, and it must be put in a red box. Okay, so this is for the today's lecture, series connection of parameters. What will be the formula? R or L are same, C are defined. Okay, so thank you for today's thank you to all of you for the today's lecture. Is reputable and benefit to you. Put a like, share to your friends, and those are new, subscribe this channel. Thank you very much for today's lecture. Thank you.